You have likely seen the videos circulating online. A person scrubbing an apple or an avocado under the sink, claiming there is an invisible, plastic-like layer that simply will not wash off no matter how hard they scrub. They call it A-peel, and the internet is convinced it is a toxic, synthetic wrapper designed to poison us slowly. The unbelievable truth is that they are half right. There is a coating, it is effectively unwashable, and it is changing the fundamental nature of the fresh produce aisle. But it isn't plastic, and it isn't a conspiracy in the way you might think. The reality is actually far more complex and, scientifically speaking, much more fascinating. We need to look at the chemistry of what is actually sitting on your counter, because the plastic theory is distracting us from the real scientific question: should we be eating fruit that has been chemically engineered to forget how to die? What A-peel actually is. To understand what is happening to our food supply, we have to strip away the marketing buzzwords and look at the molecular structure. A-peel is not a plastic wrap. It is a lipid barrier. Specifically, it is composed of purified mono and diglycerides. If you look at the ingredient label of almost any ultra-processed food, from peanut butter to ice cream, you will likely see these compounds listed. They are fats. In nature, these lipids exist inside the peels, seeds, and pulp of all fruits and vegetables. They are the building blocks of the plant's natural defense system. What A-peel Sciences has done is isolate these specific lipid molecules from agricultural byproducts, things like leftover grape skins from wine production or other fruit scraps, and reconstruct them into a powder. When this powder is mixed with water and sprayed onto produce, it dries into an incredibly thin, invisible film. The company claims this is just using food to protect food, which sounds harmless enough. And strictly speaking, from a toxicology standpoint, it is. These are lipids found in human breast milk and are formed naturally in your gut when you digest olive oil. However, the viral panic about toxic cleaning chemicals needs to be addressed immediately because it undermines legitimate scientific scrutiny. There is a British cleaning company called Evans Vanadine that produces a hard surface cleaner also named A-peel. That product is dangerous if ingested. The internet conflated the two, leading to terrifying but false claims that we're eating floor cleaner. We are not. We are eating a highly purified, plant-derived fat layer. But here is where the science gets murky. The FDA classifies these mono and diglycerides as generally recognized as safe, or GRA. This designation allows companies to bypass rigorous, new drug-style testing because the ingredients have a history of common use. But there is a massive difference between a lipid existing naturally within a grapeseed and that same lipid being industrially extracted, concentrated, and layered over a cucumber that you are about to eat skin on. The gap between chemically safe and biologically appropriate is where the real controversy lies. We are essentially taking the natural armor of a fruit and supercharging it with a concentrated, lab-created reinforcement. It is edible, it is tasteless, and it is odorless. But just because something is edible does not mean it belongs on a fresh apple in high concentrations. The unwashable nature of this coating comes from the fact that these are lipids, fats. Think about trying to wash bacon grease off a plate with just cold water. It doesn't work. These lipids bond to the waxy cuticle of the fruit, creating a barrier that water alone cannot break down. You aren't washing it off because, chemically, it has become part of the surface. The preservation mechanism that defies nature. The reason this lipid barrier matters isn't just because it's hard to wash off, it's because of what it does to the biology of the fruit. All fresh produce breathes. It is a living organism even after it is picked. It takes in oxygen and releases carbon dioxide and water vapor. This process, called respiration, is what eventually leads to ripening and, ultimately, rotting. It is the natural life cycle of organic matter. Apeel works by hacking this respiratory process. The coating creates a physical barrier that drastically limits gas exchange. It keeps moisture inside the fruit and keeps oxygen out. By controlling the flow of these gases, Apeel effectively puts the fruit into a state of suspended animation. It dramatically slows down the rate of oxidation, the chemical reaction that causes browning, and prevents water loss, which causes shriveling. On paper, this is a miracle for food waste. It can double or even triple the shelf life of an avocado or a lime. But here is the twist that defies nature. The coating preserves the exterior asterisk appearance of the fruit far more effectively than it preserves the interior asterisk nutrients. We rely on visual cues, color, texture, firmness, to tell us if food is safe and nutritious. A shriveled lemon tells you it's old. A brown avocado skin tells you it's overripe. Apeel breaks this evolutionary signal. Because the skin is sealed in this lipid armor, it stays green, firm, and glossy for weeks longer than it naturally should. Meanwhile, the internal chemistry of the fruit continues to change, albeit more slowly. This leads to a phenomenon consumers are reporting more frequently: the zombie fruit. You buy an avocado that looks perfect, hard, green, flawless. You wait for it to ripen. It sits on your counter for 2 weeks, refusing to soften. Finally, when you cut it open, the inside is brown, stringy, or rancid. The exterior shell was preserved, but the internal structure eventually broke down anaerobically or simply aged in a way that the skin didn't reflect. The disconnect is jarring. We are used to fruit rotting from the outside in, or at least showing us signs of distress. This technology decouples the visual freshness from the actual physiological age of the produce. Furthermore, by sealing the surface so tightly, we are altering the microbiome of the fruit. Natural spoilage is often driven by bacteria and fungi that break down organic matter. While slowing this down reduces waste, we have to ask what happens to the biochemistry of a fruit that is trapped in its own respiration byproducts. Are we preserving nutrition, or are we just preserving the aesthetic of freshness? The science suggests that while we are winning the war against shriveling, we might be losing the battle for honest food quality. The fruit looks alive, but chemically, it is often a ghost of what you think you are buying.